Now we'll talk about what are called one-to-one functions. So one-to-one functions have unique x values and unique y values. So in other words, for every x value, there is one y value, and for every y value, there is one x value. They pass the horizontal line test and the vertical line test. And if you start with a function and you know it's one-to-one, then you know that its inverse relation will also be a function. So I just want to revisit this line. So if you have a function and you're trying to decide if it's one-to-one, first, if your original function passes the vertical line test, that tells you that it's a function, right? So that your original is a function. And then if your original also passes the horizontal line test, remember that that confirms that its inverse relation is also a function, okay? So graphically, if we're looking at what are functions, so all three of these in number 2, they're all functions, right? They all pass the vertical line test. Yes, yes, yes. They all pass the vertical line test, but we want to know if they're also one-to-one functions. Then in addition, we have to apply the horizontal line test. So starting with the one on the left, here's a horizontal line, intersects my graph twice. So no, it's not one-to-one. So this represents a function, but not a one-to-one function. Okay, it passes the vertical line test, but it fails the horizontal line test, so it's not a one-to-one function. Second example, we could use the x-axis. Hits 1, 2, 3 times there. Not a one-to-one function. So this is a function, but it's not a one-to-one function. Okay, so yes, it's a function. Yes, it passes the vertical line test, but no, it's not a one-to-one function. Now, when we get to this last example, yes, it passes the vertical line test, and any horizontal line is only going to intersect once. So we have our first yes. So this is not only a function, but this is specifically a one-to-one function. Okay, so this is the only one of the 3 that's a one-to-one function. So what that means, well, it means a lot of things. But one thing that it means is if we were to create the inverse relation, which is symmetric about y equals x, that inverse relation would also be a straight line that's a function, right? It would pass, the inverse would pass the vertical line test because the original passed the horizontal line test, okay? And if we took the inverse of the inverse, we'd get back the original. Everything's a function. So the original is a function, the inverse is a function. They pass the horizontal and vertical line tests. Okay, so suppose that we're given an equation and we want to find the equation for the inverse of a one-to-one function. This is our notation. We call it f inverse of x. F inverse of x. So again, if we're trying to find an inverse, I want you guys to think about switching x and y. So you'll see that that's here in step 2, right? So that's the key, interchange x and y, switch x and y. All right, so your steps for finding the formula, the equation for a one-to-one function, the inverse of a one-to-one function. So let's kind of go through these steps using this original equation here. So suppose this is my original function, f of x equals 5x plus 4. And by the way, if I wanted to graph that, remember that that's the same thing. That's the same thing as y equals 5x plus 4. So y equals 5x plus 4. Okay, and we just get this straight line. So if we wanted to graph it, I'm kind of skipping ahead a little bit, but if we wanted to graph y equals 5x plus 4, we could use the trace key or just plug in numbers. For x equals 0, we have y equals 4. For x equals -1, we have y equals -1. For x equals -2, we have y equals -6. So let me go ahead and graph this and then we'll keep going. So -2, -6. There's 1 point. -1, -1. And then 0, 4. All right. Drawn that a little straighter, but pretend like that goes right through 0, 4. So it's a very steeply sloped straight line, right? So I can see that if I apply the horizontal line test, my inverse is also going to be a function. So let's go ahead and find the equation for that inverse. So step 1 up here says replace f of x with y. So that's right here, right? We already did that. So f of x equals 5x plus 4 becomes y equals 5x plus 4. And then step 2, I'm going to switch x and y. So instead of y equals, I get x equals. Instead of 5x, I get 5y. So I end up with the equation x equals 5y plus 4. So that's step 2 right here. Now, as soon as I complete step 2, that means that I'm writing an equation for the inverse. So now I'm writing out an equation for the inverse. So x is the equation for the inverse relation. I just want to solve this for y. That's going to be step 3. So I could subtract 4 from both sides. So this gives me, just putting 5y on the left, 5y equals x minus 4. And then I divide all the way across by 5. So either I could write y equals x minus 4 over 5, or if I wanted to, I could write this as y equals, for example, 1/5 x minus 4/5. Either one will be fine. Just to match up with what I have down here, I'll stick with this version. So the final step is replace y with f inverse of x. So this is just a function notation thing. So f inverse of x is x minus 4 over 5. So now we have my inverse function. Not just an inverse relation, but now we can certify that it's an inverse function. Okay, so if we want to graph the inverse function, I could type this into my graphing calculator, or I could simply just switch the x and y values. So in my original, I had -2, -6. That becomes -6, -2. -1, -1 will stay. And then 0, 4 becomes 4, 0. So let's plot these 3 points. So -6 and -2 right there. -1, -1, just plotting that on top. And then 4, 0. All right, so there's my inverse. Equals x minus 4 over 5. So this is the inverse function. And then in purple, I have my original function. My f of x equals 5x plus 4. And notice that when I graph them, they are symmetric about the line y equals x. So this is my line y equals x. A function and its inverse will always be symmetric about the line y equals x.